Okay, I am Professor Joyner. My students in my class know me. This is Math 1316, Business Math 2 or Business Calculus. And what this is my video lecture to make up for not being in the classroom tomorrow. So we're covering section 12.1. The title of the section is Indefinite Integrals. I'll explain all of this with some examples as we do them. On page 820, the author gives you a set of integral rules. I have repeated those, but as I often do, slightly modified his notation to what I think is better. And so the first thing you're going to want to do is copy these rules. This fourth line right here is not really a rule, but it's an example that my students tend to appreciate seeing. And so it's an example of rules 1 and 2 put together, which we often do. Actually, this fourth rule you won't see on page 820. It comes before, but it's just as good to put it right here the way that I've done it. So let me encourage you, pause the video, copy these rules down, and we'll be using these for the rest of the examples that I do as I work problems from chapter 12, section 1. And I'm going to give you a moment to pause the video. I'm going to erase these and then do problems using these rules, and just restart the video once you've got these rules copied down. Thank you. Okay, I assume that you have the rules copied, and from here on out I'm going to be working examples out of the problem set showing you how to do them. So let me start with problem 6 on page 823. Now, we're going to use the rules to evaluate each of these indefinite integrals. There are some other names for what we're doing. Another way of saying what we're doing, I want to take this function x to the fifth and find the anti-derivative of it. I want to find what function did I take the derivative of in order to get this. On the first example or two that I do, I'm going to do some extra things a little bit over and above what the book asks us to do in order to find this anti-derivative or indefinite integral. Now, I'm going to apply the fourth rule that I put up in order to find this, because this example, x to the fifth, matches that fourth rule if you have x to the n. And the way we're going to do this is this antiderivative. I'm going to take that x to the fifth, I'm going to add 1 to the exponent. That's the, if this is n, this is the n plus 1, looking at that fourth rule. I'm going to multiply by 1 over n plus 1. And then I'm going to put this crazy plus c at the end of it. And I'll explain in just a moment what it means. But first of all things aside, this is the answer you're going to see when you check your answer in the back of the book. This 1/6 x to the 6th plus c is the indefinite integral of x to the 5th. Or it's the antiderivative of x to the 5th dx. What is that dx? Don't ask right now. It's something that needs to be there, will be there. I'll explain it when y'all get back to class on the next day. For right now, it's just something that you're going to see as part of the notation of these problems. Now, let me explain to you what it is we've just found. We found the antiderivative of this function, and all that means is, if I were to take this function, so we're going to check our answer. If I were to take y equals 1/6 x to the 6 plus any constant, that could be plus 3, plus 9, plus 17, it does not matter. It's what we call an arbitrary constant. If I were to take that and ask you to find the derivative of this using your derivative rules from the very first part of the semester, the way you take the derivative of a constant times a function plus a constant, you put that constant first and then times the derivative of x to the 6th would be 6 times x to the 6 minus 1. The derivative of a constant would be 0. If you take this and simplify it, 1/6 times 6 would be 1, x to the 5th, and then excuse me, that should be 0. If you add 0, you'd have 6 times 6 would be 1, x to the 5th plus 0 would be x to the 5th, what we started with. Now, what I need you to realize is that on every problem I do, I could do this. I could check my answer like I've just done. I'm not going to take time to do it. You can as many times as you need to get a feel for this, but I'm just going to tell you, when we take the antiderivative or the indefinite integral of x to the 5th, this is what we'll get. You get this arbitrary constant because, see, I could have put 1/6 x to the 6th plus 7. Well, what's the derivative of 7? 0, and it would disappear and it would not be part of your answer. Wouldn't that be true if that were 77? Wouldn't it be true if it were 777? That's why C is an arbitrary constant. Now, whether you like it or not, it needs to be written in your answer. When you take the indefinite integral of x to the 5th using rule 4, this is what you get. I want to see that plus C, that arbitrary constant. If I don't, I'll deduct a few points from your score. So there's our first example. Now the great thing about doing this on a video, like we've done it, is that you can pause this, you can go back and rewind it, you can look at it again as often as you would like. Okay? Let's do, I'm going to do, almost number 10. Y'all that have had me in class know that I'm fond of doing this when I'm not particularly fond of the example that's in the book. So I'm going to take number 10 and we're going to look at it as the antiderivative of 3 plus x to the 4th dx. If you look at problem 10 the way it is in the book, which we'll do in just a second, you can see that it's very similar to this. So how do you do this antiderivative? Well, first, we're going to use Rule 3, which says that if you have an antiderivative of a couple of things being added together, I have terms in an expression. I can find the derivative by evaluating the antiderivative of each term. So I'm going to take and rewrite my original problem like that. That is Rule 3. And then, what is the antiderivative of 3 dx? Well, if you will look at my example that I did, where I combined rules 1 and 2, that's the same thing as 3 times the antiderivative of dx would be 3x plus c. Over here, what is the antiderivative of x to the 4th? Well, that would be add 1 to the exponent and then take 1 over that, or the reciprocal of that exponent, plus c. And so I have 3x plus c plus 1/5 x to the 5th plus c. Now, I'm about to run out of room in what I'm videoing right here, and so I'm going to erase the first line. You can go back and pause this or look at that as much as you need. But if I take these two terms, and if I combine them, I have 3x plus 1/5 x to the 5th. Now, what do you get when you combine this arbitrary constant with this arbitrary constant? If this were 3 and this were 8, it would still be a constant. And so you will often do this in taking antiderivatives. You combine your arbitrary constants and just put them all together as one arbitrary constant at the end. And this is the answer that you'll see in the back of the book. And so the antiderivative of 3 plus x to the 4th dx would be 3x plus 1/5 x to the 5th plus c. I'm not going to take time to do it, but if you were to check your answer, if I took 3x and took the derivative of 3x, y equals 3x, the derivative of 3x would be 3. If I took 1/5 x to the 5th and took the derivative of that, 5 times 1/5 times x to the 4th and simplify to x to the 4th, and that's what you would get. So you need to try some of the homework problems that look similar to problem 10 and try this. Let's do the real 10 now. And you will be able to see how it was very similar to what I just did. So here's problem 10, the way it's written in the book. You have the antiderivative of 5 squared plus x to the 10th dx. And what the book is trying to get across here is that 5 squared is a constant. There's no x in this, is there? You do not want to try to apply the power rule, rule 4, to this. What you want to do is think of this like this, and then integrate that term by term. The integral of 25 would be 25x. The integral, or the antiderivative of x to the 10th, would be 1/11 x to the 11th plus c. That's the answer. You will see in the back of the book when you do number 10 the way it was written in the text. The purpose that they had in putting this problem the way they did is for you to not get confused and say, oh, I need to use the power rule on this first term. Well, no, you don't. You don't use the power rule on a constant. 5 squared is just another way to write 25, and you do that problem exactly like I've done. What else can I say? Try some and see what you get. Okay, we're going to do another one. Let's try problem, let's do almost 12. Suppose I had this. I want to find the antiderivative of x to the 2/3 dx. Okay? Well, that's x to a power. This is your n. And so in order to do this, I'm going to take 2/3. I'm going to add 1 to that. That's going to end up being x. 2/3 plus 1 would be 2/3 plus 3/3 would be x to the 5/3. I'm going to multiply 1 over 5/3 times that plus c. Now, this is a little confusing the first time many of my students see it. But here's what we're going to do. In plain English, if I take 2/3 and add 1, well, 2/3 plus 3/3 would be 5/3, and that's the exponent. I'm going to show you one other thing I'm going to do here in order to simplify this. No one writes 1 over 5/3. The way you read this and apply it, the reciprocal of 5/3 is 3/5. And so your answer is going to be x to the 5/3. Take the reciprocal of that, which is 3/5, and that's what you're going to write as your answer. And that's what you'll see in the back of the book, and that's the quick, easy way to do this. So when you get ready to do one, like almost 12, all you do is you say to yourself, okay, if I take x to this power plus 1, 2/3 plus 1 is 5/3. 1 over 5/3 is the reciprocal of 5/3. The way you take the reciprocal of fraction is you just flip it upside down. And that's the answer that you'll see in the back of the book. And you can do a problem like that in about 5 seconds. Add 1 to 2/3, which gives you 5/3, and that's the exponent there. Take the reciprocal of 5/3, and that's 3/5, and that's what goes out front using Rule 4, which is often called the power rule, plus c. Now I'm going to do something I said I wasn't going to do on every problem, but I'm going to do it here. If you wanted to check this answer to see if it's correct, then what if I had y equals 3/5 times x to the 5/3 plus some constant? And what if I took the derivative of that? Well, y prime would be 3/5 and constant, the coefficient, times this function. The derivative of this function using your power rule for derivatives would be 5/3 times x, subtract 1 from that. You'd have 2/3. 3/5 times 5/3 would cancel, and that would be your derivative, and that's what we started with right here. Now I'm going to do the real 12 the way it was written in the book. Again, you can always pause this, replay it, go back and look at that. and see what you have. The real 12, the way it's written in the book, is let's take the integral of 8 plus x to the 2/3 power. How do you take the integral of that, or the antiderivative? Well, first of all, you see that you have two terms. You're going to think of it like this. You may or may not end up writing all of this. And then you're going to take the derivative, the antiderivative of each of these terms. Well, the antiderivative of 8 dx from the previous example that we did is just 8x. The antiderivative of x to the 2/3, add 1 to that exponent, and you get 5/3. Multiply by the reciprocal, which would be 3/5 plus c. And there you have your answer. It's a simple process. It takes about 30 seconds to get this if you do it without me stopping to take time to explain every part. And this is the antiderivative of what we started with on problem 12. Let's do another one. Let's try problem 16. Okay, now, just like when we're taking derivatives, we would never try to take the derivative of a radical. The first thing we would do with this is we would rewrite this as the antiderivative of x to the 3/2 power. The way you simplify the square root of x to the 3rd is you write it as x to a rational exponent. The 3, the power, goes in the numerator, the index of the radical, and if you're taking the square root, that's the second root, and that goes in the denominator. And now you'll take the derivative of this term by term, the antiderivative of 7, you'll take the antiderivative of that. The antiderivative of 17 is 17x. On the 3/2 power, you'll add 1 to that exponent. 3/2 plus 1 would be 5/2. Multiplied by the reciprocal of that, 2/5 plus c, and you are finished. It takes a little bit of practice to get into where you do this automatically. Think of this like this. Use your derivative rules, but it's a very quick, simple, easy problem. Let's do another one. Let's work number 18. The first thing we'll do with this is I'm going to factor the 3 out. The second thing I'm going to do with it is I'm going to write the cube root of x squared with a rational exponent. That would be x raised to the 2/3 power. It's always written as a rational exponent. This exponent, this power, over that root. And then I'll apply my power rule, so I have a constant 3 times x, add 1 to that. 2/3 plus 1 would be 2/3 plus 3/3 would be x to the 5/3. And multiply by the reciprocal of that power out front. I'm using the power rule, rule 4, of those original rules that I wrote down. And finally, you'll simplify that, multiply the 3 times 3/5, and that would be 9/5 x to the 5/3 plus c. And that's what you'll see in the back of the book when you check your answer on a problem like this. Let's do number 20. Okay, what a real mathematician will do with this is he'll think of it like this. He'll factor that, he'll write it like this. X to the fifth, 6 over x to the fifth would be 6 times 1 over x to the fifth. And everybody with any experience using properties of exponents would write 1 over x to the fifth as x to the negative 1/5. Then you will factor that 6 out and take the antiderivative or the integral of x to the negative 1/5. So you're going to have 6 times, add 1 to that exponent, negative 1/5 plus 1 would be x to the 4/5, multiplied by the reciprocal plus c. 6 over 1 times 5 over 4, you could cancel there, you'd have 2 there and 3 there, and you'd end up with 15 halves x to the 4/5 power plus c. And that's what you'll have on that when you check it in the back of the book. Okay, another one. Let's do problem 22. So we have the antiderivative of 2dx over 5 times x, the square root of x to the third. What you're going to do is use a little bit of algebraic simplification on that. Think of it like this. Now, how did I get from the written problem to this? I broke this apart into 2 fractions. 2/5 times 1 over x to the 3/2 would be what you have there. If you have 1 over x to the 3/2, that'd be the same thing as this. Would be the same thing as 2/5 times 1 over the square root of x cubed. That would be the same thing as 2/5 times 1 over x to the 3/2. The square root of x cubed would be the same thing as x to the 3/2 power. And then finally write that with a negative exponent. To take the antiderivative of this, factor your 2/5 out front. Add 1 to the negative 3/2, that would be negative 1/2. The reciprocal of negative 1/2 is negative 2 plus c, and that would be negative 4/5 x to the negative 1/2 plus c. Now I'd be tickled to see your final answer written like that. It may be that the book will do this. And write the final answer like so. Now, this would be fine. This would be fine. For me, this would be a good answer. And that's how you do that. Let's try number 24. You have several terms. We're going to end up integrating this term by term. But I'm going to change the way that that last term looks. So I'm going to rewrite this like so. How did I get from the original problem to this? Well, the first one is easy. You see that. If I wrote the integral of 7 dx, I could factor the constant out using rule 2 of that first set of rules that I gave you. And actually, you know what? You would do one more step. Factor the 3 out right there. And think of that like that. Okay, write it down if you have to. Now, we're going to integrate term by term. I'm going to use the power rule here. Add 1 to the exponent, that'll be 4. Multiply by the reciprocal. The integral of 7 times dx would be 7x minus 3 times. Add 1 to that exponent, you'd have negative 3. Multiply by the reciprocal plus c. That would be 1/4 x to the 4th minus 7x, negative 3 times negative 1/3 would be plus x to the negative 3 plus c. And you'll have something like that for your answer. Okay, now I'm going to pause and I'll put this assignment up on the website, but you should be able to look at these examples. After looking at these examples, you should be able to understand the problems that were in the book, and you should have no problem doing problems 5 through 29. Odd, of course, in the textbook. Try these before class Tuesday. If you have any problem, email me or text me and show me your work, and I'll try to help you out. And that concludes our lecture. Good luck on those. I don't think it'll take a lot of time. And like I said, email me or text me and holler at me if you need any help. Thank you.